So here a situation is given that in which of the following diagrams is the torque about point O equal in magnitude to the torque about point X in the diagram above. So here we have a situation in which a force is acting here. Okay, so corresponding to this force, the torque about this point X, how much that will be? Torque about point X. So what's the formula for the torque?
Perpendicular force times the radius.
That is force times its distance from the axis of rotation, perpendicular distance. So here it is L. So that is the torque about point X, right?
Yeah.
And here we have to check out of the given options that which option is corresponding to this much torque. So if we look here, this force is acting along this line. So there is the perpendicular distance of this force 2F from point O is 0. So the torque in this situation will be 0. For point B, if you check, this is force F. This force is acting at a distance L by 2 from the axis of rotation, and this is the perpendicular distance. So here torque about point O is F times L by 2. So this is wrong. So if you check here, this is 2F and here L is the distance, so we will consider only that component that is perpendicular to L. So I am considering this component. So that is what? 2F cos 60 degree. So what is F cos 60 degree, or what is simply cos 60 degree? What is cos 60?
0.5.
Yes, 0.5, or you can say 1 by 2. So finally you will get F. Now this F times L. So the torque about point O is F into L. So it is exactly equal to the torque about X. So option will be C. Right?
Yeah.
So we have a turntable that is initially at rest, is set in motion with a constant angular acceleration alpha. What is the angular velocity of the turntable after it has made one complete revolution? So this is the turntable, and its initial angular velocity is 0. It is at rest and it is set with a constant angular acceleration alpha. What is the angular velocity of the turntable after it has completed one revolution? Question is very simple, straight away, question straight away. Which formula we can use here? Or you can just imagine or consider this situation analogous to the situation of linear motion also. So as I have told you in the last class, that if you know linear equations on the same way, analogous to that, you can write the formula for the circular situation or the rotational motion. C. Check. There he is saying that the situation is for constant angular acceleration. So for constant linear acceleration, these were the equations. So for constant angular accelerations, we have this set of equations. Right?
Yeah.
So for the given question, we will use this equation. See, omega square minus omega naught square equals 2 alpha theta. You have to calculate the final angular velocity. Initial angular velocity is 0, 2. Angular acceleration is given theta. Angular acceleration is alpha, and theta. Theta is how much? For one complete revolution, what is theta? Theta is 2 pi. So omega will be equal to under the root 4 pi alpha. Option C. So it's simple question, right?
Yeah.
So a wheel with a rotational inertia I is mounted on a frictionless axle. The angular speed omega of the wheel is increased from 0 to omega f in a time interval t. What is the average net torque on the wheel during this time interval? Read carefully. What is the average net torque? Initial angular velocity 0.
Yeah.
We have the final angular speed omega. Okay, the given time interval delta t is capital T. Okay, so when the wheel has started rotating, this means what? Definitely a torque is there, because without a torque
Yeah.
it cannot achieve rotation. So the torque, and he is asking about the average torque, then that will be equal to what? That is equal to the rate of change of angular momentum with respect to time. On the same way of the force, as we have learned earlier, that is equal to the rate of change of momentum with respect to time. So what is the angular momentum? Change in angular momentum, final angular momentum minus initial angular momentum by corresponding time interval. What is the formula for the angular momentum? That is moment of inertia times omega. Initial angular velocity is 0. So the average torque is I omega f by t. Now what is the moment of inertia of a wheel? So wheel is basically what? Disc, right? But he has not put
Yeah.
that formula for this wheel. He has kept this as it is, I. So if we look at this formula, that is I omega f by t. So the option is D. Otherwise, what is the formula for the moment of inertia of a disk? If m is the mass and r is the radius, we have done this last time, that is equal to mr square by 2. Mr square is for ring or the loop, but for the disk it is mr square by 2. Question number 12. What is the average power input to the wheel during this time interval? What is the average power? It's very simple. Average power is equal to tau times omega average. You know that formula?
No, but I know power.
Power is basically, you can say, work done per unit time.
Yeah.
Work done is what? Force times displacement. So
Yeah.
if this is an average force, or this is force and this is displacement by time, so that would be average velocity, right?
Yeah.
So then that would be average power. So on the same, in the same way I am doing here, so I have written here. Okay.
Okay.
Because you have not, you can say, done these parts earlier. Okay, because you are just filling the gaps as instructed by your instructor. So this problem is due to this section. So this average power is stored into this. So what is torque? Average torque we have calculated, na?
Yeah.
Into average velocity. So what is torque? Torque is I omega F by T. And what is the average velocity? What is the average velocity? That is omega F plus 0 by 2. So that is I omega F square by 2t. So I omega F square by 2t. So that is option number P. So this will be the answer.
Okay.
Clear?
Yeah.
So here we are given with two blocks. This is M1, M2. It is and joined with a string that is passing over a pulley, and this pulley has radius r and having moment of inertia I about its center. T1 and T2 will be the tensions in the string on the either side of the pulley, and alpha is the angular acceleration of the pulley. Which of the following equations best describe the pulley's rotational motion during the time the block accelerates? Now the block is accelerating, right? Now see, first we have to rectify this diagram because he has given that this is tension. So we always use tension arrows in pair, and the arrows of the tension must act away from the bodies. Okay.
Okay.
Now what's the weight of this? That is M2 into G. Clear?
Yeah.
Then this force, what is the net force here? What is the net force acting here? That is M2G minus T. So if I consider this block 2, M2G force is acting downwards, T2 is acting in the upward direction, so it will come down with acceleration A, right?
Yeah.
So when it comes down with the acceleration A, so what you can write? You can write M2G minus T2, that is M2 times A, right?
Yeah.
Okay. And this is mass M1. If this is coming down with an acceleration A, because it is connected directly with a string, single string, so it will also move with acceleration A in the forward direction. Now what is the force that is acting on this mass M1? That is creating this acceleration A, so that is only this force T1. So if this is equation 1, so for this mass M1, the force that is acting in the horizontal direction is T1. So we can write that T1 equals to mass times acceleration. So that is your equation number 2, right?
Yeah.
Now if we look at the pulley having radius r, the force of tension is acting in this direction, another force of tension is acting in this direction. Now what these two forces of tension are doing here? So both these forces will create a torque about this center of the disk. So when this mass is coming down, this means the sense of rotation of this disk will be clockwise, right? So from here you can write T2 times R, because the perpendicular distance of this tension about the center of the disk is R. minus T1R, because that is the net torque that is acting here. That is equal to what? I times alpha. It is given, na? It is I times
Yeah.
alpha. Okay. So from here you can write T2 minus T1 times R, that is I into alpha. Okay.
Okay.
So I have done the analysis of every part. So if we look at the options, so this option C seems to be correct. T2 minus T1 into R into I alpha, right?
Yeah.
For other parts he has not asked that much. For other parts then we have to calculate the situation. Okay.
Okay.
Suppose I substitute the value of T1, not T1 can't be substituted, so then we have to use all the three equations to solve this problem. Simply if we see, if I use equation 1 and 2 and try to find out the difference T2 minus T1, so what I can write, this is T1 minus, you can reset this equation, that is T2, that is M2G minus M2A. So if I write T1 minus T2, so that would be M1A minus M2G plus M2A. So from here you can write T1 minus T2, that is equal to M1 plus M2 times A minus M2G. So if you substitute the value of T2 minus T1 from this equation into this equation, okay, it is T2 minus T1. So this is so T2 minus T1 will be what? That is M2G minus M1 plus M2 times A. So if you substitute this value here, okay, so you will not get this equation because one part will be missing then, right? And
Yeah.
also there is a negative sign is there, so so you can get equation number 4. So the right option is option C. Question number 10 and 11. Read this statement first. So what is the net force that is acting? The cylinder is suspended in mid-air.
Yeah, it does not move.
So this means what? The sum of force is 0. Okay. When the sum of force is 0 means what? From the center of mass of the cylinder, let this point is C, the weight will act in the downward direction, so that is mg, right?
Yeah.
And which other force is acting?
Normal.
Not normal, that is T. but T is not acting here. T is acting at this point, so we can't show this force to be acting through this. He is saying that the center of mass does not move, means the acceleration of the center of mass is basically zero, means it is not moving. So when it is not moving, this means what? This means the net force is zero. This means what?
Net force is 0.
Net force will be zero, na?
Yeah.
So when the net force is zero means what?
It's
The
not
net force
moving
on
at
the cylinder during this time interval must be zero. Clear?
Yeah.
So we cannot show it by this diagram, because this force is acting here, this force is acting here. They are not along the same line. Okay. So net force acting is zero, because he himself is saying that the cylinder is suspended. 11th question. The linear acceleration of the person's hand during the time interval is, or we can say that this is valid, because what are the forces that are acting on the disk? Only two forces are acting on the disk.
Yeah.
So that is mg, and the another force is the tension force. There is no other force, because for the forces the sum of forces has to be zero, because single force cannot be zero, na? Because weight is acting.
Yeah.
So there must be some other force that is cancelling it, and in this picture we have only other forces as the tension. Okay. So from this, if from the first question, if acceleration of center of mass is zero, from here then we will write tension must be equal to mg. But what we have to calculate? We have to calculate the acceleration of the person's hand. Now acceleration of person's hand means what? The acceleration of this point P. The acceleration of this point P. So that point P is the point on the string. So whatever is the acceleration of point P is the acceleration of the string, or the acceleration of the man's hand. Now when tension is acting here, now this tension will create a torque in this cylinder. So what is the torque here? Tension times R. So this is the torque. This force will create the torque about the center of the disk. Now this torque will be equal to I times alpha, right? So
Yeah.
and we have to calculate the linear acceleration. So what's the relationship between the angular acceleration and the linear acceleration? So the linear acceleration is r alpha. So alpha is basically a by r. So I a by r, so that is t. So in place of t, here it is given t, so I will keep that t, that is r. So this will be t r square divided by I. So that is the linear acceleration.
Yeah.
So what is the tension? If you put the value of tension, that is mg r square. What is the moment of inertia? It is half mr square. So this r square and r square will get cancelled, m and m will get cancelled. So finally we will get the linear acceleration as 2g. B is the option, right?
Yeah. Okay.
So you can consider all the questions as the standard questions. These are the, I am doing this just like just for the illustration, so that you can get the idea that in different situations how we have to use the different formula and equations. So a block of mass m is placed against the inner wall of a hollow cylinder of radius r that rotates about a vertical axis with a constant angular velocity omega as shown above. In order for the friction to prevent the mass from sliding down the wall, the coefficient of static friction mu between the mass and the wall must satisfy which of the following equations. So this block is, I think, greater than equal to, and this block where it is square is given, it is, I think, is omega. Okay, because it's a misprint in the book.
Oh, okay.
Analyze this situation. The requirement is that we have to prevent the mass from sliding down the wall. Now, due to the weight of the block, definitely it will come down.
Yeah.
Okay, but our requirement is that it must not come down. So how it will be in that particular position? How this block will be kept in that particular position? So suppose friction will act on this box in the upward direction, and this friction has to balance the weight of the block. Only then this is possible.
Yeah.
So the force of friction must be greater than equal to the weight. Clear?
Yeah.
Then m is given to us, coefficient of static friction is known to us. Then what? Why this whole situation is given? It is kept in this cylinder and this mass is moving
In a
along with
circle.
it is moving in a circle. Now in order to move in a circle, an object requires what?
Torque and centrifugal
Hmm?
force.
Yes, it will require a centripetal force. So what that force here is?
The angular velocity.
Hmm? That is the normal reaction that these cylindrical walls will provide to this mass. Okay, it is the normal reaction, na?
Yeah.
Why? Because when you rotate this mass along with the cylinder, so this mass will be thrown in this direction. So it will press the walls of the cylinder with this much force. Okay, so you can say the pressing force. It will press the walls of the cylinder with this force, and in lieu of this force you will get a normal reaction in this direction. Now what is the force with which it will press this? So this force is equal in magnitude with the normal reaction, and this normal reaction is responsible for the particle to continue its motion in the circle. So what will be the value of n? That will be m r omega square, right? And its magnitude is equal to the pressing force. Now if we know this normal reaction, so what is the force of friction? So that is coefficient of static friction times m r omega square, right?
Yeah.
So if we talk about the limiting value, so I will write mu r omega square equal to g. So omega square is g by mu r. Okay, we have to calculate mu. So mu is equal to g by r omega square. So this is the minimum value, or otherwise you can write mu must be greater than equal to g by r omega square. So if the coefficient of friction is greater than equal to this value, so this block will not come down. Clear?
Yeah.
An ice skater is spinning about a vertical axis with arms fully extended. If the arms are pulled in closer to the body, in which of the following ways the angular momentum and the kinetic energy of the skaters affected? So you must have seen in the ice skating, then when skater pulls his arms inward, her rotational speed increases.
Yeah.
So why this is so? This is just because of conservation of angular momentum. Now what conservation of angular momentum says? That if no external torque is acting, then the angular momentum will remain conserved. So that is initial moment of inertia, initial angular velocity, final moment of inertia, final angular velocity. So when skater pulls her hand inwards, so this is the skater, initially her arms are extended and she is rotating with an angular velocity omega. Now in such a situation she has a moment of inertia I, right?
Yeah.
Okay. Now when she pulls her arms inwards, then what will happen? The angular momentum will remain same, but the moment of inertia is decreased because the mass is not extended, na? Because moment of inertia is what? Mass into square of the perpendicular distance from the axis of rotation. So she has pulled her arms inwards, so basically she is reducing her moment of inertia. So this product has to remain constant. So if the moment of inertia is decreasing, this means the angular velocity will increase. So the angular momentum will remain constant, but the kinetic energy will increase, right?
Yeah.
Now look at this question number 2. A particle of mass m moves with a constant speed v along the dashed line y equals a. When x coordinate of the particle is x naught, the magnitude of the angular momentum of the particle with respect to the origin of the system is. So you have to calculate the angular momentum about that point. So from the definition of angular momentum, we know that that is m v r perpendicular. So the linear momentum of the particle is given, that is mv. We can just look this from the diagram, no issue. But what is the perpendicular distance of this linear momentum with the point with respect to this point O? So that is by default what? A. So the angular momentum of the particle with respect to origin is mva, right?
Yeah.
So this will be the answer, right?
Okay.
So it's suggested that you should practice questions, as many questions as you can, because this chapter I have told you that it's relatively difficult because it requires lot of abilities and you have to remember so many things also, right?
Yeah, I'm practicing.
Okay, okay then.
Okay.
Okay.